Okay, good morning. Welcome to
FamilyMath number 992.
FamilyMath 992. So today I'm going to try to explain some very basic ideas in a very short note I saw from Nassim Taleb yesterday. So Nassim studies very advanced problems in probability. Not usually things that are accessible to kids, but he's studying something really interesting here. And it relates to what we did yesterday with the coupon collector problem. So the title of his paper is What You See and What You Don't See, the Hidden Moments of a Probability Distribution. And what the problem he's studying here, if you remember the graph of what our coupon collector problem, the number of trials looked like. So here was 5. Yep. And let's say here was, I better draw it a little more smushed together. Am I still on screen?
Yeah.
All right. Do you remember what it looked like when we ran a whole bunch, like 100,000 or 1,000,000 trials? How often did we get 5 and 10 and 20? What did that curve look like?
It was kind of like, it was 0, and then it just popped up, and then it went like up a little bit more, and then went down like that.
Okay.
It wasn't exactly linear.
No, yeah, that's fine. I just want you to give what you think a sketch of it would be.
So it started at 5, and there were a lot of trials that had 5, so it sort of went up almost like this. You have to like here, and sort of curved out. And actually, I think it went down a little faster.
Okay, yeah, you don't have to get it perfectly. I don't.
It's like that. There was almost nothing.
Yeah, then it was almost nothing for a little while.
Yeah.
And so the interesting thing here, so what this curve tells us, in some sense, well, first of all, why were there no values below 5?
Because it was impossible. We had to get 5 things.
We had to collect 5 things, so you had to take at least 5 trials.
Yeah.
And why do you think there weren't very many? Like, why do you think it didn't take 80 trials? Hardly ever.
Well, you need to avoid one number a lot. So it's basically, once you get everything, it's 4/5 to a very large power, and that gets really small.
Yeah, so if we were trying to collect these 5 coupons that were distributed randomly in cereal boxes, so it's very similar to rolling a 5-sided dice.
Yeah.
Mm-hmm.
And so you wouldn't expect it to take 80 times to see all 5 numbers once.
Yeah.
Because you would have to say not roll a 3 80 times in a row. Pretty unlikely.
Mm-hmm.
And the first time we did it with 100 trials, we saw, I think our largest one was like 34, if I remember right.
Something like that, yeah.
Does that sound right?
Yeah, it was around 35.
Mm-hmm.
35, I think it was a little less.
Okay, and do you remember what the largest we saw total when we
I
did
think
like
it
a
was
1,000,000 trials?
67?
Yeah.
Okay, so if we ran 1,000,000 trials, sometimes we saw, really avoiding a number for a long, long period of time. Yeah. And so what Nassim is studying here, not in this situation, in fact in this situation it's quite a bit more complicated, but he's saying, like, if you ran like in our simple situation, let's say you ran like 1 billion trials or something, and we saw a nice curve that kind of went down like this. But if you did only 100 trials, maybe your maximum would be 34, like we saw here. We saw 34. We didn't see any more than that. And then we saw some in here, and we would have a much choppier thing because we're doing a small number of trials. Maybe it just looked like that.
Yep.
But what he's specifically trying to understand is, because remember he said what you see and what you don't see. He's specifically trying to understand what it looks like over here when we can't see that, because we only ran 100 trials.
Mm-hmm.
Like, how do we know, when comparing to the maximum we saw, what do these other, like, rare chances and low probability think? But, like, what are the chances of getting 40, or what are the chances of getting 50 or 70 or 80? But you're going to have to run millions or billions of trials to know that.
Yeah.
So what do you think you could do to learn about the things you're not seeing?
Well, you mean like the chance of ending up at those?
Yeah, right. The chance of, say we ran 100 trials and we got 34 is the most. do you think we could say anything about like what the chances of getting 40 was, or what the chances of getting 50?
I mean, you can say that it's less, and it's probably kind of exponentially less,
Oh, interesting. And
kind of based on the graph.
maybe it's exponentially less. Okay.
But with one run, you really can't say too much. Like
You've got
Like,
to do it multiple times.
maybe the average, like maybe your average maximum was 50 and you just got a low one, or maybe the average max is 20 and you just got a high one.
Okay. Good. And what do you think?
Well, I guess you could sort of look at the scale, like the range of maximums if you do a lot of trials, maybe like 100, and you could see what the maximum of the maximums was and sort of zoom in on that.
Okay. Yeah, so it's a challenging problem, and where something like this might come up, just as an example, and this example is different than our coupon collector problem, is we might have a record, for example, of floods that have come in an area, and maybe we know how high the water got every now and then, and we were trying to decide how high to build the wall. And we knew that of the things we saw, 34 was the highest it ever got. And we were trying to decide, should we build the wall 34? Do you think that would be a good idea?
Well,
It's the highest you'd ever seen.
yeah.
I mean, you'd think you'd be safe, but
Probably
you don't know
wanna
what's going to happen
do
in
it
the
a little
future.
higher than that.
How much higher do you think you would want to build it if you saw 34?
Well, not too much higher. Maybe like just like one or two.
1 or 2 more? Okay.
I mean, maybe build it like 10 feet higher. So maybe if there's like a really, really bad storm that you weren't expecting, you'd still be safe.
Yeah, but you can see it's a tough problem. You got to estimate what's going to happen out here. That you have to estimate from the things that you haven't seen yet how high to build it. So it's a challenging problem. So I'm going to show you some results I did on the coupon collector problem based on Nassim's work.
Okay.
Right?
All right.